Welcome! Today we'll introduce you to EVORIS, our intuitive solution for the smart and easy digitalization of complete plants and production processes for the forming industry. My name is Hahn and I'm Sales Director of the Forming Business Unit. You may ask yourself how the digitalization of an entire plant can be done easily. Jonas Schmid, our EVORIS product owner within the Forming Business Unit, Patrick Störner, Software and Digitalization AI Expert at Diefenbacher, and I will show you how this can be accomplished. First, let's have a brief look at what benefits manufacturers can achieve by using EVORIS and how the entire system works. Then, we will dive deeper into EVORIS. You'll also hear from our partners about our joint development approach and from our customer Autoneum about their EVORIS experience. With EVORIS, Diefenbacher has developed a new approach to the digitalization of hydraulic press systems and complete plants. The EVORIS platform will provide deeper insights into your production processes to help you make better and faster decisions. The result is higher production capacity. Because EVORIS helps you to quickly identify and eliminate errors, you can also increase technical availabilities and reduce unplanned downtimes. This in turn leads to saving raw materials and costs. Of course, product quality is also another important topic covered by the EVORIS apps. You'll be able to improve and maintain product quality and, as a side benefit, improve product documentation. To deliver these advantages and help you get the most from EVORIS, we developed it as a browser-based and manufacturer-independent system. In this way, you can connect any kind of machine to EVORIS. You also benefit from a modular app structure design, which makes EVORIS easily extendable. EVORIS collects and processes sensor and actuator data throughout the entire plant. Then, self-learning AI-based EVORIS applications like Anomaly Detection turn that data into useful, easy-to-understand information. You can access these data and operate EVORIS from any mobile or desktop device within your plant's network. If questions arise, our expert will be there for you anytime, from design through implementation and training to ad hoc service. Of course, you can count on us to continuously develop EVORIS and provide you with regular updates. And now, Jonas will explain how EVORIS is integrated into your plant.
Hi, my name is Jonas Schmid. I'm pleased to welcome you here today. Let's see what the entire EVORIS system looks like. It starts with collecting data from all machines in the plant. For example, from the extruder, the robot and the press for an LFTD line. Data is stored in a central database. The heart of the system is the EVORIS Start Center. From the Start Center, you can select and operate all EVORIS apps that help you to analyze and evaluate measured machine data. Every app can access the data in the database and process it according to function. Also, third-party apps and other databases can be connected or integrated. Basically, this is how EVORIS works within your plant. Of course, EVORIS isn't just for LFTD plants. It can be used in SMC, tailored blank lines, and in metal forming plants. As well for all our individual machines, whether it's a press or a fiber con. Let's take a quick look at the smart core features and apps of EVORIS. EBA is our partner for data acquisition. They provide a powerful database that collects your plant data on edge and allows camera integration and trending, combined with the web-based Start Center that allows you to use all apps for powerful analysis and evaluation using the collected data from the plant, we have created a solution for comprehensive connectivity and transparency. Anomaly detection, curve analysis, and component history are the 3 apps for in-depth analysis and condition monitoring. Anomaly detection constantly monitors your production process with the help of AI and warns you in case of deviations from normal production. This allows you to react proactively to increase plant availability. With curve analysis, you can easily analyze complex processes to better understand current production conditions and to optimize the process in total. Component history collects data concerning the total loads on components. You can evaluate these loads over your components' entire life cycles to create better plans for proactive maintenance. The following apps will be available soon. The Hydraulic Monitoring app monitors your complete hydraulic system and informs you about condition changes supported by AI. The Actual Value app allows you to check machine component states directly at the machine with a mobile device. The Reports app provides you with in-depth production reports no matter the shift, day or specific kind of reporting. To make your plant's digitalization as easy as possible for you, we provide comprehensive support right from the start. To meet your targets and requirements, we design EVORIS together with you and implement it together with you. We train you and your team comprehensively and will release functional updates on a regular basis. Of course, all our newly delivered machines will be ready for EVORIS.
That's a short overview of EVORIS. During its development, we collaborated extensively with key stakeholders. Fraunhofer ICT, IOSB and our customer Autoneum were among those who helped us create technology that is both cutting-edge and customer-driven. As part of our long-lasting partnership with Fraunhofer ICT, we are researching how to adapt our machines to prospective requirements. Now, let's hear from Professor Henning, Institute Director Fraunhofer ICT, about our partnership and its advantages for the forming industry.
Digitalization is an indispensable building block in tomorrow's sustainable lightweight design. For this reason, Diefenbacher and the Fraunhofer ICT have worked together for many years as research partners in the area of lightweight technologies. Concerning EVORIS, the aim is to combine the latest methods of digitalization and complex AI algorithms in the platform and to integrate them into smart production. This can decisively increase sustainability in production. In addition, manufacturers can achieve consistent production qualities that have not been possible to this extent yet. EVORIS creates completely new perspectives and visions to the production of composite components by means of AI predictions and anomaly detection. The digitalization platform from Diefenbacher will be continuously developed and updated. Thus, it can enhance lightweight design and technologies and become a real success factor. At the new Research Factory Forschungsfabrik in Karlsruhe, innovative machine and plant manufacturers, such as Diefenbacher, will have unique opportunities to research and develop the topic of intelligent production on real processes in a practical manner, together with the Fraunhofer ICT, the Fraunhofer IOSB, and as well the KIT Institute for Production Technology, WBK.
Thank you, Professor Henning, for sharing your impressions with us. Later on, you will see the contribution of the IOSB and the experience of our customer Autoneum. But now we want to show you what the newly developed platform looks like. Let's hear more from our software and digitalization expert Patrick Störner.
Thanks, Marco. Hi, I'm Patrick. Let's dive deeper into EVORIS together. You remember this graphic that my colleague Jonas showed you in the beginning? As already mentioned, the EVORIS platform consists of the EVORIS system and the EVORIS Start Center from where all apps can be operated. First, let me explain the EVORIS system. The core of every digitalization system is data. To collect this data, we connect EVA to all the data sources in a plant. Here, we use already proven connectors from EVA to different PLC manufacturers like Siemens, Beckhoff and Rockwell, or other standard industry protocols like OPC UA or MQTT. All collected data is stored in one centralized, time-based database. The EVORIS apps can connect to this database and get all the data they need to perform their tasks. When we integrate the system into your plant, it's configured for all relevant signals and parameters. Of course, you can add signals, whether for test cases or modifications in the system with just a few clicks. To conclude, EVA is our partner for a manufacturer-independent digitalization of machines or the entire plant. It allows central data acquisition and processing and allows secure data storage on edge. Fast error identification is possible through camera integration. It is definitely a powerful trending and reporting tool.
Now, we will give you some insights into the EVORIS Start Center. Our EVORIS Start Center is browser-based. You can operate EVORIS everywhere within your plant's network, on a stationary PC or on a mobile device. There's no software installation needed. EVORIS simplifies your daily routines through helpful widgets. Let me summarize. The EVORIS Start Center is modular and browser-based and enables flexible expansions of the functions via apps. The intuitive and modern user interface makes operation easy. Ongoing updates give you maximum operational reliability and performance. You are also able to save time through individually designed and saved dashboards. So Patrick, let's see the first new app called Curve Analysis.
During the production process, hundreds of signals from the entire plant are continuously recorded and stored. The Curve Analysis app is our solution to enable easy access to all the data from everywhere on the local network, be it the machine HMI, a PC in the office, or even a tablet in the press pit. The Curve Analysis app is browser-based and touch-compatible. It's easy to use and allows much easier communication due to the view storage function. Different views can be configured by the machine personnel, and these views can be shared with others.
The Component History is an app that collects valuable data for total loads for various components in your plant. Data can be viewed and compared inside the app. This makes it easy to get an overview of the load during the complete life cycle of your components and identify rare and long-term trends. Let me give you an example. If you want to buy a car and you know that it was driven for 100,000 kilometers, you only get a rough idea about its conditions. With more information about how the car was driven, whether in summer or winter, or on highways or off-road, you get a much better idea. This is what the Component History is doing in your plants. It's collecting valuable information for all wear parts in the plant. So you have a much better idea of the condition of your plant. But there is more you can do with Component History. For example, a task can be set up to monitor the eccentric load during the pressing process. By comparing this data to the previous batch, information about the stability of the process can be displayed in an easy form. Without the app, you would have to dig through lots of time series data to identify any similarities or differences. The Component History app shows you loads over time, even decades, in a simple plot. You are able to find correlations between signals and discern long-term trends. A retrospective view gives you the option to compare the loads of rare parts with their predecessors in order to estimate the condition of the current part.
The Anomaly Detection app is just for our EVORIS platform. You can get this only from Diefenbacher, and you should. It detects deviations from target values during production, which makes life simpler for the operator. No difficult setup, no threshold selection, no worries. You just defined what you want to observe, for example, your extruder and your press. What's great is that the app learns as you use it. Once trained, the app will notify you of every deviation from expected production conditions in the current situation. Imagine the change for your operators. Instead of hundreds of single values to keep track of, now they check just one single anomaly score. When the score is too high, the app shows you the signals that cause the anomaly. This enables you or your staff to react early and target any problems in your plant. But that's not all. You can also set up several anomaly detections to monitor different parts of your plant. These will all act independently of each other and warn you if anomalies are detected in their scope. To combine the process expertise of ICT with the latest machine learning and AI methods to create self-learning apps, we work closely together with the Fraunhofer IOSB. Dr. Hasterok and Dr. Pfrommer, let's talk about your contributions to EVORIS.
The Fraunhofer Institute IOSB has a strong focus on artificial intelligence applications in large real-world systems. As such, we have worked with Diefenbacher for many years on successful research and development projects. For the development of EVORIS, the team of the IOSB combined the latest scientific advances in the field of artificial intelligence with the expert knowledge of Diefenbacher. The first AI-based services from this cooperation are already available to customers, and they provide new insights into production processes. Specifically, anomaly detection enables plant operators to achieve a higher OEE and reduced material and energy consumption, together with controlled and predictable product quality. The developed technology thus contributes to a more efficient and sustainable production. The Fraunhofer team for this cooperation was led by Dr. Hasterok. Dr. Hasterok, please tell us more about these technologies.
The aim of the EVORIS apps is to support operators of Diefenbacher plants and their decisions. For this, we analyze real-time process data using state-of-the-art AI algorithms and combine it with the insights of Diefenbacher's technology experts. This combination results in models that can be transferred between process installations, and in addition adapt themselves to the characteristics of each individual process. The smart algorithms also allow manufacturers to use the app for different products, product variants, and under changing production conditions. Customers will continue to benefit from this research partnership between Diefenbacher and Fraunhofer in the future. They can expect regular updates, innovative new functions, and the latest technology as part of the EVORIS development.
Thank you, Dr. Hasterok and Dr. Pfrommer, for your insights into the collaboration on EVORIS. With our anomaly detection, you can monitor all desired production parameters, machines, and components. You can detect production deviations early and take proactive and fast countermeasures, leading to fewer or shorter production downtimes. And you're able to better avoid repeated errors, plan preventive maintenance measures, and make shift handovers easier.
This completely new digitalization approach found its first application at Autoneum in Switzerland. We are happy that Mr. Collard, Legal Unit Head and Plant Manager at Autoneum, is willing to share his experience with EVORIS and discuss our cooperation.
At Autoneum, we are always looking for new and innovative ways to optimize our production. With EVORIS, Diefenbacher is pursuing a new approach to digitalization that seemed promising to us from the very beginning. The use of a browser-based platform that integrates artificial intelligence makes the operation of our LFTD systems, which we use in the production of our underfloor products such as battery trays, faster and more efficient. Since EVORIS can be used flexibly, the system is very interesting and the right solution for us. Our employees already work with many important EVORIS apps. We expect the continuous development of the software to provide us with sustained support in optimizing and developing our established production processes. Since the introduction of EVORIS at Autoneum, we have worked closely with Diefenbacher's specialists. This started with the design and integration of the digital solution in our plant and continues in the further development of EVORIS. Innovations are discussed, implemented and evaluated in collaboration with technologists and artificial intelligence experts and regularly updated. We see great advantages in contributing our wishes and requirements directly to the development. In this way, the software in our plant is constantly improved in accordance with our needs. We have achieved particularly positive results with Anomaly Detection and other apps for diagnosis and condition monitoring. AI-based anomaly detection informs our operators directly about deviations in the production process, which make us aware of potential problems at a very early stage. This gives us the opportunity to detect errors and take countermeasures to avoid production downtime. For example, a faulty control system was detected and rectified during the first installation of an AI-based app, enabling us to reduce the energy consumption of the plant significantly. The digital platform also allows us to achieve consistent quality. This shows that digitalization is a key to sustainability and profitability at Autoneum. That's why we're excited about future EVORIS apps and how AI and machine learning will help us continuously optimize our production.
Thank you, Mr. Collard, for sharing your experiences with us. You mentioned that you are curious about upcoming EVORIS apps. Well, we are working on this at full speed. Here's a look at this and how they will help you to operate your plant even better. Soon, we will release various analysis and condition monitoring apps, including hydraulic monitoring, actual value and reports. Imagine you are standing somewhere in the plant right next to a machine making strange noises. Just pull out your smartphone, scan the tag number of the component with your actual value app, and you can see all the live values you normally see only on the control panel. The future will include plant-wide hydraulic monitoring to power up your preventive maintenance measure to the max. Consider oil changes. They are a cost-intensive part of hydraulic press maintenance. In the past, oil changes were recommended after a fixed time. In the future, we will know all relevant influences on the aging of the oil and their occurrence. This gives you a data-based estimation on the current state and an estimation for the remaining useful life. The Reports app will provide you with reports on your plant that give you deeper insight into production, availability and overall consumption. And of course, we will keep on releasing new apps to reach the ultimate goal of a self-optimizing plant.
I hope this first comprehensive view of our digitalization solution EVORIS has been helpful. I want to thank you for your attention and your interest. If there are any questions, we'd be happy to answer them and to discuss how EVORIS can help move you and your business forward.
Collecting signal data is not everything you can do with EBA. It's also possible to include camera records in the data for an even more detailed view of what's going on in your plant. Collecting data is one thing, analyzing it is another. And here EBA also has a powerful solution. Let's see what this looks like. In this demo, we see a typical workflow in the EBA analyzer. On the left side, I have all the signals from the plant grouped into clear modules. With drag and drop, I can add signals to existing graphs or create new ones. Inside the graph, I can perform any operations you would expect from a powerful trending software. For example, I can zoom in vertically and horizontally, make an overlay of two correlated signals, and measure the exact values. But that's not all. As mentioned, we are also able to add video streams into the database. These streams are synchronized with the rest of the data, so I can view them in parallel. If I move the marker in the graph, the frame from this moment will be displayed in the video window. By clicking on the play button, I am able to run the video in real time or even slow motion. Now I can see what exactly happened with the material at the robot gripper without being limited by sensor data. To conclude, EBA is our partner for a manufacturer-independent digitalization of machines or the entire plant. It allows central data acquisition and processing and allows secure data storage on edge. Fast error identification is possible through camera integration. It is definitely a powerful trending and reporting tool.
EVORIS simplifies your daily routines through helpful widgets. On the left side, you can see all installed apps and, in the middle, your personal dashboard, which can be designed and optimized to the needs of each user. So you can choose the apps needed and simply put them on your dashboard. For example, a Diefenbacher Messenger shortcut. You can also add other widgets such as a calculator, weather forecast or the Diefenbacher parts catalog, which helps you to simplify your daily routine and communication. When there's an update, you will be informed by the integrated EVORIS App Store, so that you benefit from performance, function and security announcements. And of course, you will be informed or even warned about anomalies and quality or condition issues, so you can take countermeasures even faster. Let me summarize. The EVORIS Start Center is modular and browser-based and enables flexible expansions of the functions via apps. The intuitive and modern user interface makes operation easy. Ongoing updates give you maximum operational reliability and performance. You are also able to save time through individually designed and saved dashboards.
The Curve Analysis app is our solution to enable easy access to all the data from everywhere on the local network, be it the machine HMI, a PC in the office, or even a tablet in the press pit. The first step in the app is selecting the measurement file or defining the time range for a database query. When the data is selected, we switch to the next tab to select the signals we want to observe in our current analysis. This list can be sorted or filtered to quickly find what we are looking for. In this example, we want to select a few signals that give us an overview of a press cycle. We'll take two signals from the RAM, its position and its velocity. As a third signal, we include the force of the press unit. For frequent analysis, we can switch to the next tab to store our signal selection or load an already saved selection. When we have finished our signal selection, we can close this window and look at the data. At the top, we see the graph with the curves of our selected signals. At the bottom, we have a table with additional information and settings for the signals. We see that the RAM was at the top at the start of the press cycle. Just a moment after the start, it began moving downwards. Just before it reaches its bottom position, the press force rises until it reaches its maximum value. After a short moment, the press force is reduced, and when this is finished, the RAM is going up again. We can do everything you would expect from a modern user interface for data analytics. By hovering with the mouse, you can see the exact values. Of course, you can also zoom in to have a detailed view of your area of interest. If you want to make a measurement between 2 points in the graph, you simply put the markers to the position where you want them, adjust them, and read the value difference that is calculated automatically. The Curve Analysis app is browser-based and touch-compatible. It's easy to use and allows much easier communication due to the view storage function. Different views can be configured by the machine personnel, and these views can be shared with others.
We start again from the dashboard of our Start Center. By clicking on the app name on the left, we navigate to the main page of the app. Here we can view the data that's already stored in the background. First, we select the component we want to view. In this plant, we have set up several components to monitor the loads on the main drives of the LFTD extruder, the hydraulic pumps, and the oil of the press. We also monitor the process stability based on the eccentric load during the press cycles. After selecting the components, you select the parameters over which the load should be displayed. In our demo, we want to see the operating hours of the oil over the oil temperature. Now we get the plot and see the histogram we wanted. On the vertical axis, we have the operating hours. On the horizontal axis, we have the oil temperature. By mousing over the bars of the histogram, we get the exact values. To refine this plot, we set the time intervals and activate a second plot to compare two intervals. In this demo, we want to compare the time range from the start of the commissioning until the first oil change with the range from the first oil change until the repair of the cooling system. In the plot, we see clearly that the oil temperature in this phase, during which the cooling system had a failure, was distinctly higher than in the phase before. So we know that the oil was under much higher strain, and we can adapt the service intervals to ensure a higher availability of our system. The Component History app shows you loads over time, even decades, in a simple plot. You are able to find correlations between signals and discern long-term trends. A retrospective view gives you the option to compare the loads of rare parts with their predecessors in order to estimate the condition of the current part.
Now let's have a close look into the app. Via your dashboard, you can easily navigate to the full screen app by just clicking on the icon on the left, the dashboard tile, or an upcoming notification. In the upper left corner, you see the anomaly score. The only thing you need to know here is this. If this score is greater than 1, we have an anomaly. That's it. All other information will be provided by the app. Next to the score meter, you can find a table with detailed information on the responsible parameters and below the anomaly over time. In this example, we see a deviation in the dosing unit combined with a torque in the extruder that is lower than we would expect in the current operating stage. Both deviations are well within the machine limits, but with the Anomaly app, they are directly visible. You can immediately initiate corrections to proactively avoid or at least shorten production downtimes. In addition to live data, you can also view historical anomalies. Just click on Historical and you can see, for example, the last 8 or 24 hours. On the left side, we have 2 plots. The upper one shows the anomaly value, which we saw on the live view. The lower one shows the relationship of the individual values to the anomaly. You can zoom in and out, gain quick insights by mouse over, or a detailed view by clicking on a certain anomaly. This makes production processes more transparent, and they can also be analyzed retrospectively. With our anomaly detection, you can monitor all desired production parameters, machines, and components. You can detect production deviations early and take proactive and fast countermeasures, leading to fewer or shorter production downtimes. And you're able to better avoid repeated errors, plan preventive maintenance measures, and make shift handovers easier.